Hey Ram, I've heard about signals and systems in electrical engineering. Could you help me grasp what they really are?
Absolutely. Ein. Think of signals as the messages that devices use to communicate with each other or with us. These messages can take various forms, such as the sound of your voice during a phone call, the pixels forming images on your screen, or even the data packets traveling through the internet.
So, signals are the information carriers?
Exactly. Now, systems are like tools that take in these signals and perform actions on them. They could be as simple as adjusting the volume of your music player, or as complex as image processing software that enhances the quality of photos.
Alright, I'm with you so far. But how do we analyze and understand these signals and systems?
Well, when we're dealing with signals, we often want to know how they change over time. That's where time domain analysis comes in. It's like watching the signal's behavior as time progresses, just like watching a movie frame by frame.
So, if I were to track how a signal changes from one moment to the next, that's time domain analysis?
Exactly. Now, sometimes it's helpful to look at signals from a different perspective. That's where frequency domain analysis comes into play. It helps us break down a signal into its individual frequencies, giving us insight into its components.
I've heard of Fourier analysis in this context. What's that?
Fourier analysis is a powerful technique that takes a complex signal and breaks it down into simpler sinusoidal components. It's like dissecting a chord in music to understand the individual notes that create it.
That's a great analogy. And what about Laplace transforms? How do they fit in?
Laplace transforms are particularly useful for understanding systems and control engineering. They help us transition from analyzing signals in the time domain to understanding their behavior in the frequency domain. It's like seeing the same thing from a different angle.
And filters, like the ones you mentioned earlier, are part of systems, right?
Absolutely. Filters are systems designed to modify signals in a specific way. They can emphasize or diminish certain frequencies in a signal. Imagine them as tools that refine the characteristics of a signal, just like adjusting the tone on a music player.
Thanks for breaking it down, Ram. So, signals are the information carriers, systems process them, and understanding their behavior involves looking at them in different ways, like through time domain analysis, frequency domain analysis, and using tools like Fourier analysis and Laplace transforms.
You've got it, Ein. Signals and systems are the language through which technology communicates and interacts with us. Whether it's sending a message on your phone or enhancing the quality of a photograph, signals and systems are at the heart of it all.
In this elaboration, Ram and Ein explore signals as information carriers and systems as tools that process these signals. They delve into time domain and frequency domain analysis, Fourier analysis, Laplace transforms, and the concept of filters. By using relatable analogies, they aim to provide a deeper understanding of how signals and systems shape our interactions with technology. Please like, share, subscribe to our channel.